This is a lesson on electric circuits, but particularly grade 12, because it has this internal resistance. But before we start with our lesson, I want us to look at the formula sheet. With your grade 12 question paper, you get your formula sheet. And what's nice about the physical science question paper is that they tell you see, like this one, they tell you electrostatic, this one electric circuit. You know exactly where to go. So all our formulas will find here where it's written electric circuit. Let us look at our question. Okay, here's our circuit. We see that we have two resistors connected in parallel, and we have another resistor that is connected in series to these two that are connected in parallel. And then we have our battery here, which has an EMF of 12 volts and an internal resistance of 0.2. The internal resistance is the energy, is the resistance that is inside the battery. When current is flowing, 12 volts will not be in the circuit. Some of the voltage will be eaten up by the battery. So that's what the internal resistance means. Okay, let's look at the first question. It says when switch S is closed, the potential difference is 11.7 volts. Here's switch S closed, so it means current is flowing. When switch S is closed, current is flowing. So some of the volts will be lost. The EMF, the battery, when you buy the battery, it will be written 12 volts. But in a circuit, only 11.7 volts will be circulating. So question A, calculate current in the battery. I want to show you formulas that you can use to calculate the current. Let's go back to the formula sheet. In your formula sheet, the first formula is this formula that says resistance is equal to voltage over current. So you're going to use that formula. Now, there are different formulas that you can use for that. Let's see. Now, when you get a question where they say calculate current, you can use three different formulas. The first one, you can calculate your current using your total voltage divided by total resistance. Now, the total voltage is the EMF, is the voltage that a battery produces. Then the total resistance is the resistance in the circuit, including the resistance that is inside the battery. The other formula that you can use is current. You can use external voltage divided by external current. What is that? The external voltage, remember when we switch off the battery, the circuit had 11.7. This is the external resistance, the external voltage. And then the external resistance is the resistance outside in the circuit, not the one that is inside. Then the third one that you can use is lost volt divided by internal resistance. Now, the lost volt, the volts that will be eaten up here, divided by the resistance, this internal resistance. Now, with this question, you need to, when you look at them, you're using the same. When you do that, your answer will always be equal and your answer will always be correct. Don't use the total voltage with the external resistance. You need to look at it properly. Okay, let's see which one are we going to use in this question. A, calculate current in the battery. The current in the battery is the total current. So you can use any of the three. Depends on what you have. Okay, when we look at our question, we have the total. We can use this one. We have the resistance here and that one. We need to calculate the lost volts, the volts that are left inside the battery. Lost volts is equals to 12 minus 11.7, which will be 0.3 volts. The 12 volts is the EMF, is the total volt. 11.7 is the volts that are revolving around the circuit. So the lost volt is 0.3. So we're going to use that formula to calculate. the resistance. Loss volt 0.3, and then the resistant in, it's actually a small letter r, not a capital letter R. It's a small letter R. It's a small letter R. The resistance inside the battery 0.2. Then you take your calculator, you calculate, you get that it's 0.3 divided by 0.2, 1.5 amps. Any formula that you're gonna use, you're gonna get the same answer. Okay, let's look at the second one. We calculate effective resistors of the parallel branch. So when they talk about the parallel branch, is that one. Now we have a formula for parallel. You go to your formula sheet. It's 1 over R parallel is equals to 1 over R plus 1 over R. So the resistors in parallel, they're like that. So the first one is 1 over 10. The second one is 1 over 15. You add them. 1 over 10 plus fraction 1 over 15 is equals to, you get a 1 over 6, right? But you remember it's 1 over parallel, so you need to swap it around. Okay, the last one, calculate the resistance of the resistor R, this resistor. So we can use this formula. It says current is equals to V external divided by resistance, external resistance. Okay, current, we find that it's 1.5 is equals to V external voltage is 11.7 divided by external current, excluding that one, is these two that are connected in parallel, which is 6. Remember, you calculated them in this question, plus this resistor that we don't know, that we're actually looking for. Okay, so let's cross multiply. That multiplied by that will be 11.7 is equals to 11.5 times 6 plus R divided by, no, it's not 11.5, it's 1.5 divided by 1.5 divided by 1.5, and then we get, let's take our calculator, 11.7 divided by 1.5, that will cancel that. That will give us 7.8 is equals to, here I'll have 6 plus R. Then I take the R to the other side, 7.8 minus, that will be my R. And then my R will be 1.8 ohms. So this is how you calculate that.